And welcome everybody to the Daily Space Weather. We're back as if we never left. So some exciting stuff going on, as is often the case here at the Smash News Network. Least busted name of news. We did a little bit of rebranding, and so let's do it. A daily, a space weather. So first of all, we have had quite a spectacular coronal mass ejection, which we'll cover. It's not earthly directed. We'll cover whether or not it's earthly directed later in the video during our coronal mass ejection section. The most active group has been indeed in that lower right quadrant there, the southwestern limb. It did produce one decent-sized M-class flare. That is our T-mass, the most active sunspot group of the past 24 hours. And before we get to any other stuff like coronal holes and so forth, let's move on to look at briefly what's going on Earth. By the way, that's a 48-hour video, and we've had some exciting CMEs, some filamentary eruptions. Are any of them particularly exciting for space weather coming up? Well, not super exciting, but let's move on to see what's going on with volcanoes. First of all, we've got Sakurajima is erupting. Also, Ibu. Semeru creating some new real estate on East Java. Dukono exploding. Popocatépetl, one of the largest eruptions in the world there, 23,000-foot ash plume. Sanchaguido, Fuego, Nevado de Ruiz, Sangay, Revenador, and Sabancaya also on the list. 7+ magnitude earthquake drought continues. There are the past 90 days. No 7 magnitude earthquakes since the end of January. So earthquake droughts end in large earthquakes. If you're in an earthquake-prone zone, be aware of this. 5 and greater magnitude quakes in the past 24 included this 5.0 at Timor-Leste. That was early this morning at 3:05. Then Tonga had a 5.2 at 7:41. Then Timor-Leste had a 5.1 at 10:10. No, at 10:20. 10:20, yes. Then Papua New Guinea had a 5.2 at 12:35. And south of Macquarie Island there had a 5.0 at 20:33. And let's get back to space. Space, a frontier. The radio flux is now at 127 solar flux units. 127 is the radio flux. A dip, along with the sunspot number. After all, they are proportional data sets. And there is sunspot number and radio flux together. Red line is sunspot number, black line is radio flux. The blue line is the AP index, which is kind of like an average of the KP index, the Potsdam AP. So let's see, what do we got? NOAA's not forecasting any geomagnetic storm activity. We've only got 1 weak CME impact currently bound for Earth. See our previous daily space weather videos for information on that. We don't go over our previous content. You'd have to be watching that. So anyway, next moving on to Earth's magnetic moment from space. So there are the past 4 hours of the Space Weather Modeling Framework's rendition of the magnetosphere, using about a dozen variables, at least a dozen variables, including the electron flux magnetic fields, the solar wind parameters. So the past 4 hours have been geomagnetically calm, as you saw there. Here's Earth's magnetic moment from the ground, similarly geomagnetically calm. This will show you the most likely places to see the aurora when we do have incoming space weather. At the moment, not so much. KP index is at 2. KP2 is the current situation. Again, it's geomagnetically calm. Solar wind data from ACE. Nominal speed and pretty diffuse, only about 2.5 protons per cubic centimeter for the density. Solar wind velocity here just over 400 kilometers per second. At the Discover, pretty similar, only about 4.25 protons per cubic centimeter there. Make it 4.4 and a 435 kilometer per second solar wind velocity at Discover. Our GOES magnetometer is shown here. Pretty smooth. No major geomagnetic storms in the past couple of days. Only some minor activity. We did have a proton event, which we will get to. Next, Earth's magnetic sector. North Pole sector continues here, and it's going to be around for a couple of days unless something drastically changes. That's the past 4 days. Next, our line of sight field plot, and we've got North Pole oriented coronal holes rotating in here. There's our coronal hole line of sight plot. And oh, we have some magnetic indecision happening over here on the eastern portion. So, that could be a place to see new sunspots likely to grow. So, there's a little bit of a forecast for you when these fields are in such opposition to each other as they are in that imagery. It's almost like a mini Terminator event. So Terminator events are when the magnetic fields are canceling each other out. Eventually one wins that magnetic tug of war, and you get a predominantly polar situation as opposed to one that's very chaotic as it is right there. That's the kind of environment where you can expect to see sunspots. When it gets very polar, now it's more likely to produce coronal holes. So before we get to any sunspot stuff, let's take a look at coronal holes. There they are. And none are very well defined at the moment. Anyway, sunspots are next, so let's cover sunspot number. Sunspot number down to about 81. 81 sunspots, according to Rob, the Royal Observatory of Belgium. Here's our flare probability monitor and scoreboard, and let's switch to sunspots from the SDO. Pretty stable here, no major changes, no major degradation, no major growth. Watch that southeastern corner, which would be your lower left. We may see new sunspots about to form there. Here is our most active sunspot, or our T-mass. Quite a lot of umbrae there, probably something like in the realm of, geez, about 60 umbrae there, maybe, something like that. And we'll briefly show our SDO magnetogram. So keep in mind this sunspot group gets more likely to produce large flares as it approaches the limb. And when we zoom out, you can see how close in proximity to the limb it is. So we're really entering a time here where we could be in an X-ray loud state for that sunspot. If it stays like it is now and doesn't degrade magnetically speaking, it'll be kind of likely to produce large flares. It is at the moment quite likely to produce large flares. Next, moving on to things like the proton flux. And we did see a little spike here. So that is associated with one of the flares that just came out of that sunspot group. And by the way, that is known as sunspot 3599. 3599, folks. And there's the one-day graph of the X-ray flux. We normally show the 3-day, and you can see this significant uptick. So that could continue. Its likelihood of producing an X-class flare now higher, and it looks like this long-duration C-class event is actually what brought the protons. 1540 was peak flux there. Protons didn't show up until, all right, right around that time. So perhaps it wasn't even from that. $15.38 maybe was peak flux, something like that. So at 15.38, what's up with that? What's up with that, folks? Oh, 3-day. So there you go. There's 15.35. 1535 was right around when that proton event happened, so some very high-speed particles there likely to have shown up. Very high-speed particles showing up practically at the same time that we saw peak flux of that flare. Anyway, moving right along here to take a look at flares from our favorite flare wavelength. Perhaps it's your favorite flare wavelength. I'm not sure. Let us know in the comments what your favorite wavelength to view solar flares is. This is 131 angstroms from SDO. So the most significant brightening you'll see is that M-class event. And there it goes. Yep. That C-class event was the one associated with that proton event. And oftentimes we see a filamentary eruption happening. So this one actually, the filamentary eruption happened before the flare, looks like. And remember, folks, we don't say on the channel that solar flares cause coronal mass ejections. It's probably more physically plausible that filamentary motions cause the flares. We've also got 94 angstroms. There. Another 24-hour video at 30 frames per second. Here on the 10th March, 2024. That is our T-mass, the most active sunspot. And before we get to CMEs, a brief look at what's going on overhead. And the sun is still up here over Lehigh Valley, Pennsylvania. That's what's going on over our head from skyandtelescope.org. We've got Sirius as well as Deneb over the early evening skies. Next, a solar system forecast and happy new moon. Hey, happy new moon to Eugene the Philosopher. If you haven't subscribed to the channel, make sure you subscribe to Eugene the Philosopher. He is the largest contributor to this channel. The Magician from Minsk. Make sure you sub Eugene the Philosopher. Anyway, here's your 1-week forecast. That's where things will be on the 17th. And here's our astronomy photo of the day. It's a total solar eclipse in Antarctica. Yes, one guy photographing another guy who's checking out his telescopic equipment. And yeah, a total eclipse at the end of the world from earlier this year on March. Oh, today. From today. Yes, very nice. Who knew? Who knew? So, there you go. A total eclipse from the end of the world. And definitely take that one out of context. A total eclipse from the end of the world, folks. Oh, my God. Dear God. Next, going to CMEs. And again, there have been some spectacular ones. Late night last night, there was one, and of course, it's right at the beginning of this movie. That's 48 frames from today. George Mason University's Coronagraph and difference imagery. Very nice. So there's LASCO C2 and C3, and let's get a little closer here. And there may be an earthly directed event, folks. I don't think there is, though. So let's just see what happens here. So there's late last night. That's not earthly directed. That's behind the northeastern limb. There's a second event coming out of the out of the southeast. Then there's a third event coming out of the northwest and out of the west. Does that one have an earthly directed component? Fingers crossed on that. Let's take a look at stereo A at about 1400 today. Ah, man. Not cool. Oh, we have the difference imagery. Doesn't look earthly directed. But here's this spectacular CME. Ah, man, that's not there either. That sucks. All right, let's move on to take a look at our custom coronagraphs, because they are totally sweet. There you go. How you like them apples? That ain't bad. Yeah, there is an earthly directed event in there. So good news, folks. Another CME to arrive on the 13th. So late in the day on the 13th, probably more like early in the day on the 14th. So expecting overnight on, let's see, what is that? Wednesday evening into Thursday. Late the 13th into early the 14th. CME impact, yet another one on the way. It came from this area right down here to the left of our Earth scale. So that one CME that happened around 1400, there was a far side event happening at the same time, but that one was a partially Earth-directed component. So always nice to have that in the forecast. A little bit of space weather coming. And don't expect it to be anything major. Probably nothing above a KP 5.67. So here we've subtracted the LASCO C3 coronagraph, and we've added to the SDO imagery 193 angstrom 60-minute running difference. Once again, that is a 24-hour, 30 frames per second video, mainly on March 10th. Great imagery there from SDO. Here's an even closer view. You get a great view of the flares, the filamentary action, and quite a lot of stuff going on there. And at least one additional CME headed in Earth's direction. We're delighted to report it, folks. Just delighted to report it. So the filamentary eruption that happened just before that proton event arrived also contains an earthly directed coronal mass ejection. Good times for space weather. Here's the region it came from. Right down in there, south of that sunspot group 3599. South and a bit east is where that Earth-directed CME came from. Also a great filament there setting down in the southwest. Here's the full southern hemisphere, since that's where the main earthly action has been. Here's where that absolutely massive CME blasted off. Right at the beginning of the video, right after it resets, you'll see it go flying. And it certainly did at some speed. Also some very dense plasma mixed in there. And that is where we'll close this thing out. So that is the end of our custom coronagraph coverage. Time to move on to filaments. So there are filaments from Cerro Tololo, and we do have some dense filaments on the Earth side of the disk, so the likelihood of CMEs remains very high. Now remember, folks, you don't need to see sunspots or solar flares to see coronal mass ejections. These are separate phenomenon. Don't get solar flares and coronal mass ejections mixed up. Solar flares are photons. Coronal mass ejections are protons. Very different features, very different phenomena. Solar flares are X-rays, and coronal mass ejections are material blasting out of the sun's atmosphere. Very, very different. Very different. People say, when is the flare going to arrive? And if it's been detected, it's already arrived. It's traveling at light speed. It's light. It's X-rays. Coronal mass ejections typically take about 3 days to arrive. And then in between there, you've got proton events. Those are relativistic particles traveling very fast as 12 minutes we've seen, maybe 10 minutes or so. So traveling a significant percentage of light speed. Sometimes those relativistic, the solar energetic particle events, as they're known, do arrive in rapid speeds. So anyway, lots of filaments on the Earth side of the solar disk is my point. Let's close out space weather, but first, bonus features. So here the past couple of hours, we do have a crown prominence at the northern hemisphere and some prominences around the limbs. Satellite charging hazards are minor, and we do have some here over the Middle East, the northern Indian Ocean region, and eastern Africa. Goes electron flux, highest levels of electron flux we've seen since December. Yeah, since Christmas, we haven't seen levels of electron flux this high, so the electrons are back. There's the 1-year graph to contextualize it from solar.info. Electrons, they're back. And by the way, those are not the ones in the outer Van Allen belt associated with the Russell-McLaren effect. Those are the electrons at the F layer of the ionosphere. Those are around 300 kilometers of altitude, not the ones in the outer portion of the outer Van Allen belt that cause the equinoxes to be more susceptible to geomagnetic storms. The geomagnetic storm susceptibility is from the Russell-McLaren effect, where the outer electron belts are accelerated. That induces more current into the system when the other parameters are favorable, like a negative BZ, high proton count, and high speed solar wind. Next is our forecast model there from NOAA, and NOAA's expecting these levels to continue. I tend to agree. We will see a dip in about 3 days because of a CME impact. But besides that, I tend to agree with that forecast. Next, the layer where it's measured, it's the F layer. Feel free to pause the video on this frame. There is the vibrational frequency of the ionosphere, and it's pretty chill. Everybody chill. It's pretty chill. So that's what's been shaken. Here's the anomaly in megahertz from a 30-day median. And of course, the main anomalies you'll see are the South Atlantic anomaly over the South American continent. No real surprise there to our regular viewers. Space weather has been calm. Next, the WHAM, the whole atmosphere model. And that just brings up an important reminder, since it is the year of the dragon, to not try to sneak up on a dragon in his own lair. That's a bad idea. Dragons are not surprisable in their own lair, so don't try to sneak up on them. If you can show up when they're not there, maybe that'll work out for you, but that might not be wise either. Anyway, there's the WHAM, the whole atmosphere model, the global ionosphere nowcast. And here is the latest intensitygram and latest colorized magnetogram. There it goes. And these sunspots have been degrading. It looks like sunspot number is going to drop between today and tomorrow. And it's time to move on to the meteorology segment. So we're starting out with a little bit of that. Yeah, a little bit of that. That is the highest sea in the world right there. That is the Southern Ocean, where we've got about 34-foot waves there. And that is the world's stormiest area, really. We've got some quite significant waves there. The rest of the planet is a lot calmer than that area south of New Zealand. That is showing significant wave height and surface winds. So let's continue on with our regularly scheduled meteorology segment, where we'll show the surface winds and jet streams of the full planet. There are the surface winds of the east. And your jet streams. Shout out to our viewers from this side of the planet. Jet streams of the central world. Shout out to our viewers from this third of the planet. Surface winds shown here. We got a northerly wind over the Mediterranean, which means some lovely hot temperatures there in places like Italy, Sicily, and those other Mediterranean islands where southern air is pushing up. Next, shout out to our viewers from the west. There are your surface winds, and there are your jet streams. Once again, surface winds, and once again, jet streams. Next, clouds and fog. That's not clouds and fog, that's visible satellite. That's way better than the shortwave radiation map. That's like a photograph. Part of the NASA GOES Interactive Weather Satellite Suite. Very nice. Next, precipitation type. We've got mixed precipitation making its way across Pennsylvania. Also in the Pacific Northwest, we've got some wet snow and rain. Precipitation type, one of the many features of Windy.com's mobile app. This, of course, is just a web page. Windy.com, you can download the mobile app if you wish. If not, I definitely don't care. Next is our weather.gov map. We're just scrolling down to show you the key. Got some freeze warnings there around some Gulf states. And some winter storm warnings around the Great Lakes eastern chapters. Next are our forecasts, starting out with pressure and precipitation from tropicaltidbits.com. Pressure and precipitation for the next 72 hours is what we're showing here. And yeah, that's a thing. That's the thing. Next, accumulated positive snow depth change in inches. Once again, it's a GFS 72-hour model. Next, temperature anomaly forecast in degrees Celsius, and that is our final forecast. Warm temperatures coming to the northern central U.S. as well as the northeast. Anyway, there's the map. That's in degrees Celsius, by the way. Temperature anomaly forecast for the next 72 hours, GFS model, degrees Celsius. Countdown to spring. Spring's only 9 days and 4 hours away when we made this video. It falls on Tuesday, March 19th at 11:06 p.m. Eastern Daylight Time. And welcome to Daylight Time. It's a delight to be in daylight time. Ah, yes. And please tell your local legislator to abolish the clock changes. I want to be like Arizona. What do you think? Let us know in the comments. I hate clock changes. They don't need to exist. People can adjust their schedules if they need to. Why do you have to change a clock? It's idiotic. It's idiotic, and it makes no sense, especially in a modern digital era. Next, look at lightning, and it's been pretty calm over the North American continent. And we ain't got no terrestrial strikes at the moment, according to lightningmaps.org. So let's move on and close this mother out with U.S. Doppler radar. Visible satellite. As lake effect snow make its way across Pennsylvania, as we get little snow squall after little snow squall. There's a lot of moisture, though, west of the Rockies. As more gets piped in from the Pineapple Express, the Pacific Water Conveyor. Anyway, welcome to the recap of the U.S. Doppler radar map, visible satellite map, and of course, the water vapor. So thanks for tuning in, folks. Congratulations on Realize the channel exists. Let us know what you think of the new branding if you've seen it. If you haven't checked out our community posts, check those out at youtube.com/smashomash/community. Also, check out the links below this very video to find all kinds of additional content all over the internet at Smashomash. Anyway, thanks again for tuning into the Smash News Network, least busted name in news. It's been a pleasure having you view the content. In the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off. And may that solar wind be at your back. Whoa!